All right, let's take a look at problem number 7. This is the second part to our Trig Equations Quiz answers, solutions. Number 7 is sin x is equal to negative cosine x plus 1. And we are looking to square both sides, which means that we'll need to check solutions. All right, so anything I do to move things from one side to the other does not help me to solve the equation because I can't create factors, so I'm going to move that cosine x to the left-hand side. I don't have to do that. I could square both sides here, but I'm going to go ahead and do this to make things a little bit easier to see. All right, this gives me sine squared x plus 2 sine x cosine x plus cosine squared x is equal to 1. And of course, these two things added together give me 1. So 1 plus 2 sine x cosine x is equal to 1. When I subtract 1, that gives me just 2 sine x cosine x equals 0. And when I divide by 2 on both sides, that reduces to give me sine x cosine x is equal to 0. I'm going to factor, set each factor equal to 0. Set each factor equal to 0. And then I'm going to start solving using the circles that we did before. So where is the second coordinate of 0? That occurs at positions of 0 and pi. Right? Remember, we don't use 2 pi because it's not included in the solution set of 0 to 2 pi. All right, and then for cosine x, we're looking for solutions on the unit circle where the first coordinate is a 0. All right, so we'll find those positions at pi over 2 and at 3 pi over 2. All right, so let's just write those out for a moment. And remember, we have to go back and check solutions. So we're looking at 0 and pi for this equation. And we're looking at pi over 2 and 3 pi over 2 for the second. But remember that we will probably have extraneous solutions. Now, to jump a little bit ahead, I'll go ahead and let you know that pi and 3 pi over 2 are extraneous solutions. Let's check them. Let's start with pi. Okay, go back to the original equation. Sine pi is equal to negative cosine pi plus 1. And if we look at the position of pi, which is negative 1, 0, cosine sine, the sine of pi is 0. And then negative parentheses, cosine is negative 1. This becomes positive 1 plus 1 is not equal to 0. All right, so pi is extraneous. Let's do the same thing for 3 pi over 2. And remember, you'll have to check all of them. So check 3 pi over 2, and that gives me sine 3 pi over 2 equals negative cosine of 3 pi over 2 plus 1. Now, go to the 3 pi over 2 position. That ordered pair is 0, negative 1, cosine sine. And so my sine of 3 pi over 2 is negative 1. And my cosine of 3 pi over 2 is 0. All right, that goes away. And you can see that negative 1 is not equal to positive 1. So 3 pi over 2 is also extraneous. All right, so our solution cannot include these two. My final solution is going to be x equals 0 and pi over 2. Ta-da! All right, let's continue with number 8. Number 8 is a multiple angle or triple angle identity. 5 tan 3x minus 5 equals 0. Let's factor out the 5. Tan 3x minus 1 And dividing by 5, of course, knocks out the 5, so it becomes 1. So that gives us tan of 3x minus 1 equals 0 would be equals positive 1. Okay, let's let u equal 3x. Do the substitution, create a slightly different equation, and look for positions on the unit circle for u, this would be for u, where the tangent is equal to positive 1, and that occurs at positions of pi over 4 and 5 pi over 4. Okay? Remember that once we have two that are exactly 180 degrees apart, that I can just write the first one in general solution form. We'll start with general solution form, and then, that's u equals, let's fix that, easy fix. U equals pi over 4 in general solution form plus, and because they're exactly 180 degrees apart, pi n. Okay? Now go back and resubstitute 3x in the place of u. So 3x equals pi over 4 plus pi n. All right, then dividing by 3 or multiplying by 1/3 all the way through gives me x equals pi over 12 plus pi over 3n. All right, that's going to be the equation that we use to find solutions on an interval of 0 to 2 pi. That is our general solution form. So here we go. 2 pi with a denominator of 12 is 24 pi over 12. All right, so our solution for x has to be strictly less than 24 pi over 12. I don't like that 4. Let's fix it. Zip. Fix the 4. Try again. All right, so x has to be less than 24 pi over 12. So let's just make some solutions here for x. X equals, let's let for the first position n equals 0. So n is 0, that gives me pi over 12. All right, when n is 1, plug in a 1 here, find a common denominator for pi over 3, which is going to be 4 pi over 12. All right, and adding to pi over 12 gives me 5 pi over 12. All right, let n equal 2. The easy thing here is just to double the top, so 8 pi over 12 plus 1 pi over 12 is 9 pi over 12. That one will reduce at the very end. We won't reduce it here. N equals 3. And 3, of course, again, I can just multiply times 4 to be 12 pi over 12 plus 1 is 13 pi over 12. And then n equals, let's just continue until we get really close to 24 pi over 12. So 4 would give me 16 pi over 12, which plus 1 is 17 pi over 12. That's pretty close. We're getting closer. And then let's try 5 to see what happens. 5 times 4 is 20. 20 pi over 12 plus pi over 12 is 21 pi over 12. That will also reduce and also happens to be less than 24 pi over 12. If I go one more, 6 times 4 is 24, plus 1 is 25, that would be too much, so we can't do n equals 6. This is as far as we can go with our solutions. Let's reduce these two. All right, so my final solutions are pi over 12, 5 pi over 12. This one becomes 3 pi over 4, divided by 3. And then 13 pi over 12 doesn't change. 17 pi over 12 does not change. And then 21 pi over 12 is 7 pi over 4. Okay, so there's my final solutions for that problem on an interval of 0 to 2 pi. All right, let's do 9 and 10. These are kind of special problems because I gave you solution positions and asked you to write it in general solution form. So number 9 gave you positions of pi over 4, pi over 4, 3 pi over 4, 5 over 4, 7 pi over 4. Okay. And then notice that between pi over 4 and 3 pi over 4, that's 2 pi over 4, which is pi over 2. All right, that's a distance of pi over 2. And so we can actually give all of our positions here as positions of starting with the first one, pi over 4. Okay, and then adding that distance for each of them because they're all equidistant apart. So x equals the first position from 0, closest to 0, pi over 4, plus, and the distance between each of these. Okay, if I do the subtraction again, 3 pi over 4, 5 pi over 4 is 2 pi over 4, which is pi over 2. So plus pi over 2n. Okay. Number 10, very similar problem. This one has solutions at sections of 60 degrees apart, okay, kind of like your hexagon. And because we know that they are 60 degrees apart, we can say that our distance between each one is pi over 3. And we can start with the 0 degree position because it is closest to 0. 0 plus pi over 3n. All right, and an easy way to write that one is x equals pi over 3n. All right, there's those two. All right, let's take a look at the last two problems here, or three problems, sorry, 20, 21, 22. Number 20 is solving by either sum and difference or by half angle. I'm going to do sum and difference for us. All right, we may come back and do half angle. Sorry, I said double angle, half angle. Sum and difference. The way I do that is I find two things that add together nicely to add or subtract to be 105, doesn't matter. I'm going to choose 45 and 60 because for me those are the easiest ones to think of. And then come off to the side, sine u plus v. Our identity for that is sine u cosine v plus cosine u sine v. Okay. Once we create that, then we go ahead and write everything out based upon this identity. So sine 45 cosine 60 plus cosine 45 sine 60. And then we will find each of those on the unit circle. So let's find that position, those two positions, 45 and 60. And remember that for 45, we get root 2 over 2 for cosine sine. And for 60, we get 1/2 square root of 3 over 2 for cosine sine. All right, and let's fill those in. Sine 45, root 2 over 2. Cosine 60 is 1/2. Cosine 45, root 2 over 2. And sine 60 is square root of 3 over 2. Okay. Multiplying on the left-hand side, root 2 over 4. And on the right-hand side, root 6 over 4. And combine like terms, root 2 plus, combine the common denominator, plus root 6 all over 4. Okay. So there's our solution for number 20. Let's see if we can squeeze in 21 here. I'll watch and see where we are on the paper. All right, same kind of thing. We're going to find cosine of 2 theta. And we're given some information here. Our given information is that cosine theta is equal to negative 6/10, which will reduce down to 3/5. Okay. And we're told that sine of theta is less than 0. That means that cosine is negative, and it means that sine is negative. And that occurs in the third quadrant, negative, negative, positive, which means that any pieces that we use, cosine, sine, tangent of theta, are going to have to fit these positives and negatives. But for right now, we're in good shape. We have 3 different identities for cosine 2 theta. Let's write them out. We have cosine squared theta minus sine squared theta. We have 2 cosine squared theta minus 1, and we have 1 minus 2 sine squared theta. I'm going to choose the one that has the least pieces in it because notice I'm given some information here and I'm given cosine. So if I use the one that only has cosine in it, I don't have to come up with the sine theta value. If I did and I wanted to use the first one, I would simply use the triangle, use my Pythagorean triples. The missing piece is a 4, and so sine theta would be negative 4/5 since it's in the third quadrant. But I'm not going to use sine theta, okay? I'm going to plug it into the second one here, 2 cosine squared theta minus 1. and we're going to solve it at that point. Cosine is negative 3/5. I'm going to square that. And then I'm just going to multiply everything together. 2 over 1 times 9 over 25 minus, and that will become a 25 over 25. Okay, so 18 over 25 minus 25 over 25, and that gives me negative 7 over 25. All right, that's about all the room I have on that page. And the last problem is number 22. All right, probably the easiest one, and I probably could have squeezed it in on the other page, but let's just go ahead and do it. This one is recognizing the form of an identity. So tangent 25 degrees plus tangent 35 degrees all over, and you'll recognize this, of course, 1 minus tan 25 tan 35 as your tan of u plus v. Okay, that's what that is. That means we let this one equal u, this one equal v, all right, all the way through u and v. And so we're just going to substitute u and v into this simpler equation. Tan of 25 plus 35, which is tan 60. And think about your unit circle in the 60-degree position here. The tan position for that one, the tan value for that one is square root of 3, positive square root of 3. So my answer is positive square root of 3. All right.